There's something deeply humbling about staring into the vastness of space, where every pinprick of light holds secrets we're only beginning to unravel. But among the countless galaxies scattered across the cosmos, one stands out for its sheer strangeness: NGC 262. This distant island of stars, millions of light-years away, isn't just another speck in the telescope. It's a cosmic curiosity shop, packed with objects so bizarre they challenge everything we think we know about the universe. Picture this: a galaxy where the usual rules don't apply. Where gravity seems to warp in unexpected ways, where celestial bodies behave like nothing scientists have ever seen, and where at least 30 strange objects defy explanation. These aren't just oddities, they're cosmic rebels rewriting the textbooks with every new observation. What makes NGC 262 so special? It's not just the strange objects themselves, though each one is a puzzle begging to be solved. It's the way they force us to question our understanding of space. Imagine a star that flickers like a dying light bulb but never burns out, or a black hole that devours matter and then spits it back out, defying the laws of physics. These aren't science fiction scenarios, they're real phenomena hiding in this distant galaxy, waiting for us to piece together their mysteries. And the more we learn, the clearer it becomes. NGC 262 isn't just a collection of stars. It's a cosmic laboratory testing the limits of what we believe is possible. So why should you care about a galaxy so far away? Because every strange object in NGC 262 is a clue, a piece of a grander puzzle about how the universe works. Whether it's a rogue planet drifting alone in the void or a nebula glowing with colors we can't explain, these anomalies remind us that space is far weirder, far more wondrous than we ever imagined. And today, we're going on a journey to uncover 30 of the most baffling, breathtaking, and downright mysterious objects in this galaxy. By the end, you might just see the cosmos and our place in it a little differently. So buckle up, we're diving into the unknown. The first marvel in NGC 262 is so bizarre it looks like it was plucked straight from a science fiction story: a glowing hexagon suspended in the void. This isn't some trick of the light or an illusion caused by distant stars. It's a massive, near-perfect six-sided structure, spanning roughly twice the width of our solar system, pulsing with an eerie, rhythmic glow. Astronomers first spotted it by sheer accident, its sides so geometrically precise they initially dismissed it as a sensor error. But repeated observations confirmed it was real and utterly unexplained. What makes this hexagon even stranger is its light. Unlike the steady glow of a star or the diffuse shimmer of a nebula, this object flickers in unpredictable patterns, almost like it's communicating. Some pulses last for hours, others vanish in seconds with no discernible rhythm. And the color, a shade of blue so vivid it defies the usual spectrum of cosmic phenomena. Theories about its origins range from the plausible to the mind-bending. One camp argues it could be a natural plasma structure shaped by magnetic fields we don't yet understand. Others point to the way its light behaves too organized, too deliberate, and whisper about artificial origins. Could it be some kind of megastructure built by a civilization far beyond our own? Then there's the unsettling fact that it's not alone. Scattered around the hexagon are smaller, identical shapes, tiny echoes of the larger structure, as if whatever created it left behind a trail of cosmic breadcrumbs. Whether natural or not, one thing's certain: this hexagon doesn't play by the rules. It's a cosmic rebel daring us to figure it out, and with every new observation, the mystery only deepens. Deep in the chaotic heart of NGC 262, astronomers stumbled upon a gravitational dance so intense it defies logic. Two supermassive black holes, each weighing billions of times more than our Sun, locked in a cosmic waltz mere light-years apart. Normally, black holes this size dominate their galaxies alone, but here they orbit one another in a tight, frenetic embrace, warping space-time like a pair of spinning tops caught in an invisible whirlpool. The discovery shattered expectations. Supermassive black holes are already monstrous, but finding two this close together, it's like witnessing two hurricanes sharing the same eye. Their gravitational pull is so extreme that nearby stars don't just orbit their slingshot into chaotic trajectories. Some flung entirely out of the galaxy, while others spiral inward, torn apart in a shower of light. Even the fabric of space itself ripples around them, emitting gravitational waves so powerful they're detectable across the universe. What makes this duo truly bizarre isn't just their proximity, it's how they got there. Conventional models suggest galaxies merge over eons, their central black holes eventually colliding. But these two haven't merged. Instead, they've stalled, caught in a gravitational standoff that could last millions of years. Some scientists speculate an unseen force, perhaps dark matter or a third hidden object is keeping them apart. Others argue their combined energy might be carving a tunnel through space-time, a phenomenon so exotic it exists only in theory. Then there's the light show. As gas and dust spiral into the black holes, the friction generates twin jets of energy so bright they outshine the rest of the galaxy. Normally, such jets shoot in opposite directions, but here they twist and knot around each other, weaving a luminous braid across the cosmos. It's as if the black holes aren't just orbiting, they're communicating, their energies entangled in a way we've never seen. Could this be a preview of our own galactic future? The Milky Way is on a collision course with Andromeda, and their black holes may one day mirror this dance. For now, NGC 262's twin titans remain a cosmic riddle, challenging our understanding of how galaxies evolve and what happens when the universe's most destructive forces decide to tango. If the twin black holes of NGC 262 left you questioning the laws of physics, wait until you see what lurks in the galaxy's outer edges. A spiral so unnatural it looks like the universe itself doodled in the margins of reality. This isn't the graceful whirl of a newborn star system or the delicate tendrils of a nebula. It's a sprawling, razor-sharp helix stretching nearly 20,000 light-years across, its arms coiled with a precision that borders on geometric obsession. The first time telescopes captured it, researchers assumed it was a glitch, a flaw in the data. But the more they studied it, the more unsettling it became. Unlike any known cosmic structure, this spiral emits no heat, no radio waves, no telltale signs of star formation. It's cold, silent, almost artificial in its perfection. Its arms glow with a faint, metallic sheen, reflecting light from distant stars but producing none of its own. Some astronomers argue it could be an extreme case of gravitational lensing, a trick of space-time bending light into this impossible shape. But here's the catch: there's no massive object nearby to warp the light that way. It's as if the spiral exists without a cause, a cosmic question mark hanging in the void. Then there are the pulses. Every 73 hours, like clockwork, the entire structure dims for exactly 12 minutes before flaring back to full brightness. No known celestial phenomenon behaves this way. Stars flicker randomly, pulsars have rhythmic beats, but nothing this deliberate, this mechanical. One radical theory suggests the spiral could be a snapshot of a higher dimensional object, our three-dimensional universe only catching a slice of its true form. Others propose it's the aftermath of an alien megastructure's collapse, its skeletal remains frozen in time. But the most haunting detail, the spiral isn't static. Over the past decade, its arms have tightened ever so slightly, as if the entire structure is slowly winding itself up. What happens when it reaches its limit? Does it vanish, unravel? The answer could rewrite our understanding of physics or reveal something far stranger lurking in the dark. As if the mysteries of NGC 262 couldn't get any stranger, astronomers have pinpointed something lurking in its spiral arms that shouldn't exist, a perfect sphere of absolute darkness. They call it the dark vortex, a swirling void roughly the size of Jupiter's orbit, where light doesn't just dim, it vanishes. Unlike a black hole which devours matter in a violent maelstrom, this anomaly is eerily silent. No accretion disk, no X-ray flares, just an inky sphere so devoid of radiation that it registers as a hole in the galaxy's fabric, the first clue to its strangeness. The way it interacts with its surroundings, stars near the vortex don't get sucked in, they slow down as if space itself thickens around it. Gas clouds curve gently around its edges like water circling a drain, only to be spat back out moments later, unharmed but fundamentally changed. Their light emerges redshifted as if they've aged centuries in seconds. Even more baffling is what happens to matter that crosses its threshold. Particles don't accelerate toward destruction, they decelerate, coming to a near stop before flickering out of detection entirely. It's as if the vortex isn't consuming matter but storing it. Then there's the dark matter connection. Galactic models suggest this region should be dense with the invisible stuff, yet sensors detect nothing, not even the gravitational lensing typical of dark matter clumps. Unless perhaps the vortex is dark matter. One controversial theory proposes it's a cosmic knot where dark matter's hypothetical particles have tangled into a stable structure, a rare peek into the shadow universe that makes up most of reality. Others argue it's something far weirder, a pocket of collapsed spacetime, a tear in the quantum vacuum where the rules we know no longer apply, the most unsettling part. It's growing millimeter by millimeter, year by year, the vortex's boundary expands. Not quickly enough to alarm anyone yet, but with a terrifying implication. What if this isn't a natural phenomenon? What if it's a process, a silent, inexorable reconfiguration of reality itself? Until we understand it, the dark vortex remains a whisper from the universe's darkest corners, one that's getting louder. Tucked away in the swirling arms of NGC 262, there's a sight that makes even seasoned astronomers catch their breath, a glittering cosmic geode floating in the void, radiating light like a shattered diamond catching sunlight. This is the crystal cluster, a massive, roughly spherical formation stretching nearly half a light-year across, its surface studded with jagged peaks and smooth plains that refract starlight into cascades of prismatic color. But unlike any gemstone on Earth, these crystals aren't made of quartz or taupe, as they're forged from materials so exotic they shouldn't exist in deep space. Spectroscopic analysis reveals a cocktail of rare crystalline compounds, including boron carbide and titanium nitride, minerals typically only found in the crushing depths of planetary cores or the searing aftermath of supernova. Yet here they are, suspended in the cold emptiness between stars, arranged in intricate lattice patterns that define natural formation processes. The cluster's core glows with a faint, eerie luminescence, pulsing softly as if breathing, a phenomenon scientists trace to trapped particles of antimatter annihilating within the crystal matrix at a rate that should have vaporized the entire structure millennia ago. Somehow it persists. How could something so delicate survive the violence of space? One theory suggests the cluster might be the remnant of a hyper-dense white dwarf that cooled and crystallized under impossible conditions, its atomic structure rearranged by gravitational forces we don't yet understand. Another, more radical idea posits that it's the wreckage of a shattered Dyson sphere, a fragment of some ancient megastructure designed to harness stellar energy, now adrift like cosmic sea glass. Then there's the mystery of its movement. Unlike rogue asteroids or comets, the crystal cluster doesn't tumble chaotically through space. It rotates with eerie precision, aligning specific facets toward the galaxy's center at regular intervals, as if responding to some unseen gravitational cue. Even stranger, deep inside, seismic sensors on orbiting probes have detected rhythmic vibrations, subtle, resonant hums at frequencies that match no known celestial phenomenon. Some researchers joke it's singing, others aren't laughing. Whether it's a natural wonder or something far more enigmatic, the crystal cluster stands as a glittering paradox, breathtakingly beautiful, yet bristling with secrets that could rewrite our understanding of how and why the universe builds its treasures. Among the many enigmas of NGC 262, few are as perplexing or as haunting as the echoing pulsar. At first glance, it appears ordinary, a neutron star spinning rapidly, its beam of radio waves sweeping across Earth like a cosmic lighthouse. But listen closely and the rhythm unravels. Instead of the steady, metronomic ticks astronomers expect, this pulsar stutters. Its signals arrive late, early, sometimes in duplicate, as if space itself is playing tricks on time. The most baffling feature isn't just the delays, it's the echoes. Every primary pulse is followed, minutes or even hours later, by a ghostly repeat. These secondary signals aren't mere reflections. They're altered, distorted, as if filtered through some unseen cosmic lens. Imagine shouting into a canyon and hearing your voice whisper back in a language you don't recognize. That's the echoing pulsar, a natural phenomenon behaving unnaturally. What could cause such a disruption? The leading theory involves an invisible dance partner, a rogue object massive enough to warp spacetime but too dark to detect. Picture a black hole or a neutron star cloaked in debris, its gravity bending the pulsar's radio waves like a funhouse mirror. As the unseen companion moves, its gravitational pull stretches and compresses the signals, creating those eerie delays. But here's the twist. The echoes don't always follow the same path. Some take scenic routes around the companion, others seem to tunnel straight through it, defying conventional physics. Then there's the tempo. Most pulsars slow predictably as they age, their spins grinding down like wind-up toys. Not this one. The echoing pulsar accelerates unpredictably, as if some unseen hand keeps twisting its dial. Some researchers speculate it's stealing energy from its phantom companion, a cosmic vampire siphoning power through gravity alone. Others wonder if the companion isn't an object at all, but a knot of dark matter, its interactions leaving no trace except these tortured radio waves. Whatever the truth, the echoing pulsar forces us to reconsider how we map the invisible structures of the universe. It's not just a celestial oddity, it's a clue. A hint that the cosmos hides more players in its shadows than we ever dreamed, and they're all whispering back to us. Nestled between the spiraling arms of NGC 262, the Mirror Nebula hangs like a cosmic disco ball, catching starlight and throwing it back with impossible precision. This isn't just another cloud of dust and gas, it's a shimmering enigma, a vast reflective surface stretching nearly 3 light-years across, where light doesn't scatter randomly but bounces back in near-perfect symmetry. Imagine pointing a flashlight at a funhouse mirror and seeing the beam return truer than it left, as if reality itself has been ironed flat. That's the unsettling magic of the Mirror Nebula. At first glance, it behaves like any other nebula, swirling with ionized particles, glowing faintly under the glare of nearby stars. But when astronomers trained their telescopes closer, they noticed something impossible: identical copies of starlight appearing inside the nebula, as if the stars had been duplicated. Not reflections on its surface, but perfect replicas deep within its structure, complete with the same spectral fingerprints and flickering variations. It's as if the nebula isn't just reflecting light, it's remembering it, replaying scenes from distant cosmic actors with zero distortion, the strangest part. These mirrored images don't fade. Light from stars that burned out millennia ago still dances inside the nebula, preserved in eerie detail. One theory suggests the nebula's dust particles are arranged in a hyperordered crystalline lattice, a natural quantum hologram freezing photons in time. Others point to the way gravity bends around it, warping space into a lens so precise it could rival anything engineered in a lab. But here's the kicker: the nebula's reflections aren't just visual. Radio waves, X-rays, even gravitational ripples from colliding black holes light years away appear inside it, duplicated down to the last ripple. It's not a mirror. It's an archive. Then there's the timing. The duplicates don't appear instantly. Some lag behind their source by days, others by centuries, with no discernible pattern. A star might explode in real time, while its mirrored counterpart inside the nebula detonates months later, as if the nebula is deciding when to replay history. Could this be a natural phenomenon or something more intentional? A cosmic message in a bottle or a glitch in the fabric of space-time? The Mirror Nebula doesn't just defy physics, it holds up a looking glass to our assumptions about how the universe remembers itself. And perhaps the most chilling clue of all, deep within its glow, astronomers have spotted reflections of events that haven't happened yet. Flickers of supernova, the birth cries of stars still forming in distant nurseries, all waiting in the nebula's cache, as if time itself is just another angle to be folded into its silver depths. Whether it's a window, a recorder, or something beyond our comprehension, one thing's certain. When you gaze into the Mirror Nebula, the universe gazes back twice. Drifting through the emptiness between NGC 262's spiral arms, the floating monolith defies every expectation of what a cosmic object should look like. This isn't a jagged asteroid or a swirling gas cloud. It's a colossal, pitch-black rectangle, its edges so unnaturally straight they look carved by intelligence. Stretching nearly 40 kilometers in length with sides perfectly aligned to galactic north, it hangs motionless against the backdrop of stars, as if someone pressed pause on its journey through the void. What makes the monolith so unsettling isn't just its shape, it's the way it interacts with its environment, or rather, the way it doesn't. Most objects in space are sculpted by external forces. Radiation erodes them, gravity tugs at their trajectories, cosmic dust peppers their surfaces. But the monolith, it's pristine, no craters, no weathering. Even more bizarre, it casts no shadow. Light bends around it, as if space itself refuses to acknowledge its presence. When probes attempted to scan its surface, their sensors returned nonsense readings that flickered between solid metal and absolute vacuum, as if the monolith existed in two states at once. Then there's the composition. Spectrographs detected traces of an alloy unlike anything in known astronomy, a lattice of metallic hydrogen stabilized by an unknown binding agent, a material that should only exist in the cores of gas giants. Yet here it is, floating in the open cold, defying the laws of thermodynamics. Some researchers argue it's a fragment of a shattered Dyson sphere, a piece of stellar engineering so advanced its very structure baffles our physics. Others point to its eerie resemblance to theoretical cosmic strings, defects in space-time left over from the Big Bang, threads of primordial energy thinner than an atom but dense enough to slice through planets. But the most chilling detail, it's not alone. Deep field surveys have detected faint thermal echoes, ghostly rectangular silhouettes scattered across the galaxy, all aligned to the same exact orientation. As if the monolith isn't an anomaly, but a single brick in a vast, invisible architecture. Whether it's a relic of a lost civilization or a natural phenomenon beyond our comprehension, one thing's clear. The universe builds in shapes we're only beginning to recognize, and some of them watch us back. There are stars that flicker, stars that explode, and then there's the phantom star of NGC 262, a celestial body that doesn't just dim or brighten but vanishes entirely for years at a time, only to reappear as if nothing happened. Imagine tracking a star for decades, mapping its cycles, studying its light, only to wake up one day and find it simply gone. No fading, no warning, just an empty patch of sky where a sun once burned. Then, months or even years later, it's back, shining exactly as before, as if it never left. This isn't a glitch in observation or a trick of cosmic dust. This is a star that defies the most fundamental rule of the universe. Things don't just cease to exist without a trace. What makes the phantom star so unsettling is the precision of its disappearances. Most variable stars dim gradually, their light waxing and waning in predictable rhythms, but this one, it winks out instantaneously like a switch being flipped. And when it returns, its spectrum is unchanged, no signs of a violent eruption, no evidence of a collapsed core. It's as if the star steps out of reality for a while, then quietly resumes its place. Some astronomers speculate it's cloaked by a shell of exotic matter, a theoretical substance so dense it bends light around the star, rendering it invisible. Others propose something far stranger, that the phantom star isn't entirely here, that it exists partially in another dimension, its gravity occasionally tugging it out of our observable universe. Then there's the timing, or rather, the lack of it. The star's disappearances follow no discernible pattern. It might vanish for 3 days, then stay visible for a century. During one stretch in the late 20th century, it was absent for nearly 12 years, only to reappear brighter than ever. The only consistency, each time it returns, telescopes detect a faint, ghostly echo of its light, a delayed pulse racing to catch up, as if the star's photons took a detour through a longer, slower path across the cosmos. Could this be a natural phenomenon or something more profound? One radical theory suggests the phantom star is entangled with a counterpart in a parallel universe, the two stars flickering in and out of existence as they trade places across the fabric of reality. Another posits that we're witnessing the star interacting with a cosmic defect, a wrinkle in space-time left over from the Big Bang, a place where the rules of physics unravel. Whatever the truth, the phantom star doesn't just challenge our understanding of stellar behavior. It forces us to ask a far more haunting question. How many other stars are out there, blinking in and out of sight, unnoticed in the vastness of the dark? Hidden in the depths of NGC 262 lies a cosmic magnifying glass so powerful it bends the rules of observation. The gravity lens. Unlike any telescope humans could build, this natural phenomenon warps space-time itself, amplifying light from objects so distant they should be invisible. Picture a pool of water distorting the view of a pebble at the bottom, except here, the water is the gravitational pull of an entire galaxy cluster, and the pebble could be a fledgling universe from the dawn of time. The lens wasn't discovered through careful planning, it was a stroke of cosmic luck. Astronomers were mapping the galaxy's outer regions when they noticed duplicates of the same quasar, an ultra-bright galactic core, appearing in multiple places at once. At first, they assumed a data error, but the truth was far more extraordinary. The quasar's light was being stretched and split by the immense gravity of an invisible structure between it and Earth. That structure, a sprawling, dark matter-heavy cluster acting like a lens, focusing distant light with precision no human instrument could match. What makes this gravity lens so groundbreaking isn't just its power, it's the details it reveals. Normally, galaxies at the edge of the observable universe appear as faint smudges, but through the lens we see them in startling clarity. Spiral arms etched with newborn stars, supernova frozen mid-explosion, even the faint glow of protoplanetary disks around adolescent suns. It's as if the universe handed us a microscope tuned to its most distant whispers. Yet the lens has quirks that baffle scientists. Unlike typical gravitational lensing, which distorts light into arcs or rings, this one often produces eerily perfect copies, like a hall of mirrors where every reflection is crisper than the original. Some amplified objects appear brighter than physics allows, as if the lens is funneling extra energy from somewhere unseen. And in rare cases, the magnified light arrives before its unaltered counterpart, a time-defying paradox that suggests space-time around the lens might be folded in ways we don't yet understand. Could this anomaly be more than a natural accident? One theory proposes the lens sits at a cosmic crossroads, a knot in space-time where multiple gravitational fields intersect, creating a lensing effect orders of magnitude stronger than predicted. Others speculate it's a window into higher dimensions where light takes shortcuts our math can't yet map. Whatever the explanation, the gravity lens isn't just helping us see further. It's revealing how much we still don't know about the fabric of the cosmos. And the most thrilling part, every time astronomers point a telescope toward it, the lens shows them something new. A supercluster's birth cry, a black hole's first meal, or perhaps one day, light from the universe's very first dawn. In a galaxy filled with mysteries, the gravity lens offers something rare, not just questions but answers written in starlight and waiting to be read. Amid the celestial oddities of NGC 262, one structure stands out not for its light, but for its voice: the radio pyramid, a three-sided colossus broadcasting whispers from the void. Nestled between two turbulent star-forming regions, this geometric enigma emits rhythmic pulses of radio waves so powerful they briefly outshine the galaxy's core. Unlike the chaotic static of pulsars or the hiss of interstellar gas, these signals arrive in mathematically perfect sequences, prime-numbered bursts repeating every 17 hours, 11 minutes, and 23 seconds, as precise as a cosmic metronome. The pyramid's shape alone defies nature. Most cosmic structures, nebulas, star clusters, even black hole accretion disks, are molded by chaos, their forms sculpted by turbulence and gravity. But its faces are smooth, its edges knife-sharp, spanning nearly 12 kilometers from base to apex. Thermal scans reveal no heat signature, no residual radiation from formation. It's cold, silent, and yet it sings. What makes these transmissions even stranger is their content. Decoded, the pulses translate into a frequency pattern mirroring the hydrogen line, the universal benchmark astronomers use to search for extraterrestrial intelligence. Coincidence, perhaps, but then there's the alignment. The pyramid's base points directly at three other anomalies in the galaxy: the Mirror Nebula, the floating monolith, and the dark Vortex. Viewed from above, their positions form a near-perfect equilateral triangle, with the pyramid at its center, too precise to be random, yet too vast to be deliberate, unless, of course, someone or something engineered it that way. Theories about its origin range from the plausible to the extraordinary. Some astrophysicists argue it's a natural maser, a cosmic amplifier where molecular clouds focus radio emissions into a beam. But masers don't build pyramids. Others suggest it's the remnant of a failed wormhole. It's collapsed exotic matter frozen into a crystalline lattice that vibrates with the echoes of a lost dimension. Then there's the most controversial idea that it's a beacon, an artifact, a monument left behind by a civilization that mastered gravity the way we've mastered radio. Supporting this last theory are the signal's subtle shifts. Every 7 years, the pyramid's broadcast changes pitch, as if tuning itself to some distant receiver. Even more intriguing, buried in the latest transmission cycle is a faint, repeating pattern that matches no known natural phenomenon, but bears an uncanny resemblance to error-correcting codes used in human digital communications. A cosmic heliograph, or the universe's most elaborate coincidence. One thing's certain: the radio pyramid doesn't just challenge our understanding of physics. It asks a far more profound question. If this is a message, who's listening, and what happens when we finally understand what it's trying to say? At the heart of NGC 262's chaos swirls a quasar unlike any other, a brilliant, raging beast where time itself seems to stutter. The time-dilated quasar doesn't just blaze with the energy of 1,000 galaxies. It bends the very fabric of reality around it, slowing clocks to a crawl in its vicinity. Imagine watching a star explode in slow motion, its light stretching like taffy as it struggles to escape the quasar's grasp. That's the eerie reality here. Time doesn't just flow differently near this object. It crawls. What makes this quasar so extraordinary is the sheer scale of its time-warping effects. Normally, quasars' supermassive black holes gorging on matter are cosmic speed demons, their jets and flares flickering unpredictably. But this one, its fluctuations unfold with the languid pace of a dying ember. A flare that should last days persists for months. Spectral lines that ought to flicker like candle flames instead drag like molasses, their light redshifted not just by distance but by time's own distortion. Astronomers first noticed the anomaly when they realized the quasar's variability didn't match any known model. Its cycles were stretched, as if someone had pressed a cosmic slow-motion button. The leading explanation involves a space-time anomaly lurking unseen beside the quasar, a gravitational titan so dense it warps time into knots. Picture a black hole spinning at near light speed, its rotation twisting space-time like a whirlpool around the quasar. Matter falling toward the quasar wouldn't just accelerate, it'd linger caught in the eddies of dilated time. But here's the twist: no companion object has been detected. The quasar appears to be alone, raising the spine-tingling possibility that the anomaly isn't a black hole at all, but something far stranger, a primordial defect in space-time, a relic from the universe's birth where the laws of physics fray at the edges. Then there's the light. Photons escaping the quasar's accretion disk don't just redshift, they arrive out of sequence. Some high-energy X-rays appear delayed by hours compared to their lower-energy counterparts, as if the quasar's gravity sorted them by wavelength. It's a violation of Einstein's equivalence principle, which states all light should bend equally under gravity, unless, of course, the quasar's surroundings aren't obeying the usual rules. Some theorists suggest the time dilation might be evidence of exotic matter, negative energy densities twisting spacetime into pretzels, or quantum foam bubbling up to macroscopic scales. But the most haunting clue lies in the quasar's past. Archival images reveal it wasn't always this sluggish. A century ago, its pulses raced at normal speeds. The time warp seems to be accelerating, as if whatever's causing it is gaining strength. If that trend continues, within decades the quasar's light might freeze entirely from our perspective, a cosmic statue trapped in amber. Whether it's a natural phenomenon or a sign of something deeper, the time-dilated quasar forces us to confront a humbling truth. Even time, the universe's most relentless constant, might be more fragile and more malleable than we ever dreamed. Floating like a spectral jellyfish in the depths of NGC 262, the bioluminescent cloud pulses with an eerie, living light. A vast shroud of gas stretching over 200 light-years, glowing in hues no nebula should produce. Unlike the fiery reds of hydrogen or the cool blues of ionized oxygen, this structure flickers in bioluminescent greens and yellows, its spectral fingerprints matching compounds we've only seen in the deepest ocean trenches of Earth. Polycyclic aromatic hydrocarbons, amino acids, even faint traces of lipids molecules that, on our planet, form the building blocks of life. At first glance, it seems impossible. These complex organic molecules shouldn't survive the harsh radiation of interstellar space, let alone congregate in such dense, structured formations. Yet here they are, woven into the cloud's filaments like threads in a cosmic tapestry. Every scan deepens the mystery. The cloud's light isn't just reflected starlight, it's generated internally, as if the gases themselves are alive, emitting photons through some unknown biochemical process. Some researchers argue it's a freak result of cosmic chemistry, where ultraviolet radiation from nearby stars trigger exotic reactions in carbon-rich dust. But others point to the patterns, the way the glow intensifies in rhythmic waves, or how certain molecules cluster together almost purposefully, like cells in a primordial soup. Then there's the motion. Most nebulas drift lazily, shaped by stellar winds. This one contracts in slow, deliberate pulses, its outer edges folding inward every 53 years like a breathing lung. Even stranger, it rotates as a single unit, its inner regions moving in lockstep despite being light years apart, behavior more typical of a solid object than a free-floating gas cloud. One radical theory suggests the entire structure might be a single, self-replicating molecule, a fractal chain of organic compounds grown to astronomical scales. Another proposes it's the aftermath of a panspermia event, where life-bearing material from one world was blasted into space and found fertile ground in this unlikely nursery. But the most tantalizing clue lies in the shadows. When telescopes peer into the cloud's densest knots, they detect structures resembling microscopic life. Not cells exactly, but swirling vortices of molecules organizing themselves into shapes eerily reminiscent of bacteria and algae. Could this be life's precursor, a halfway point between chemistry and biology, or something entirely new, a form of cosmic metabolism we've yet to define? The bioluminescent cloud doesn't just blur the line between life and non-life. It dares us to reconsider whether that line ever existed at all. And if this cloud can form organic complexity on such a scale, what else might be brewing in the dark corners of the universe, or even closer to home? Tucked within the swirling expanse of NGC 262 lies a cosmic puzzle that looks less like a galaxy and more like an intricate snowflake, the fractal galaxy. This tiny structure, no larger than a globular cluster, spins with arms that branch and rebranch in perfect self-similar patterns, each curve echoing the larger whole. It's as if someone took the grand design of a spiral galaxy and shrunk it into a recursive masterpiece, where every zoom reveals another layer of spiraling arms within arms. Unlike the chaotic mergers and collisions that shape most galaxies, this one appears meticulously crafted, its symmetry defying the randomness of the cosmos. What makes the fractal galaxy so baffling is how it exists at all. Traditional galactic evolution models can't explain its structure. Gravity alone shouldn't produce such precise, repeating patterns, especially on this scale. Most galaxies form through clumps of matter collapsing under their own weight, their shapes distorted by collisions and tidal forces. But its branches unfold with mathematical precision, each segment a near-perfect replica of the last. Some astronomers suggest it's the aftermath of a freak gravitational resonance, where waves of dark matter or unseen magnetic fields sculpted the gas into this eerie symmetry. Others propose something far stranger, that the galaxy is a snapshot of a multiverse bubble, a pocket where the laws of physics tweak the rules just enough to let fractal geometry govern stellar formation. Then there's the motion. The fractal galaxy doesn't rotate like a normal spiral. Instead, its outer arms move in lockstep with the inner ones, a synchronized dance that violates Kepler's laws of orbital motion. Stars at the edge should crawl compared to those near the core, yet here, they speed along as if tethered to some invisible clockwork. The only comparable phenomena are rare, human-made experiments with ferrofluids in magnetic fields, where liquids form branching shapes under precise conditions. Could the galaxy be caught in some cosmic magnetic web, or is its structure a hint that gravity behaves differently in this corner of the universe? The most tantalizing clue lies in its light. Spectrographs reveal that the galaxy's branching arms aren't just structural, they're chemical. Each layer contains distinct ratios of heavy elements, as if the galaxy built itself outward in waves, with each generation of stars leaving a unique fingerprint. It's a galactic onion, its history written in concentric shells of metal-rich and metal-poor stars. Normally, stellar winds and supernova would mix these layers into a homogeneous soup. But here, they've been preserved, frozen in place like rings in a tree trunk. Whether it's a natural oddity or a sign of deeper physics at play, the fractal galaxy forces us to reconsider how complexity emerges in the universe. It's a reminder that even in the vastness of space, nature sometimes writes its laws in patterns far more intricate and far more beautiful than we ever imagined. Among the wonders of NGC 262, few are as mesmerizing or as melodic as the singing comet. This isn't just another icy relic drifting through the void. It's a cosmic choirboy broadcasting ethereal radio harmonies as it streaks through the galaxy's outer reaches. Unlike the static crackle of solar winds or the erratic bursts of pulsars, The singing comet's emissions are eerily musical, mathematically precise frequencies that form chords, scales, even sequences resembling ancient earthly melodies. It's as if the universe composed a symphony, and this comet is its instrument. What makes this celestial performer so extraordinary is its composition. Most comets are frozen rubble piles, chunks of ice and dust held together by weak gravity. But the singing comet's core is laced with exotic metallic alloys, its icy shell interlaced with crystalline structures that vibrate like tuning forks when struck by solar radiation. As the comet nears stars, their heat causes these crystals to resonate, converting thermal energy into radio waves with uncanny musicality. The result: a haunting, ever-changing composition that shifts with the comet's journey, its song reflecting the temperature, pressure, and even the chemical makeup of the space it traverses. Researchers first noticed the phenomenon when deep space radio telescopes picked up a repeating pattern in the otherwise noisy background of the galaxy. At first, they assumed it was interference, perhaps a glitch in the equipment, but as the signals persisted, their true nature became clear: harmonic overtones, rhythmic pulses, and even what sounded like deliberate pauses, as if the comet were breathing between notes. The closest comparison, a glass harp where fingers running along the rim of a wineglass produce pure, resonant tones. Except here, the fingers are cosmic rays, and the wineglass is a mountain-sized hunk of space ice. The comet's repertoire is vast. Some days it emits deep, droning bass notes, likely caused by low-frequency vibrations in its core. Other times it shifts to flute-like trills, probably stemming from surface ice fracturing into delicate filaments that quiver in the solar wind. Most intriguing are the moments when multiple frequencies overlap, creating chords that match the harmonic series found in human music, suggesting that the mathematics of beauty might be universal, transcending worlds and species alike. Yet the singing comet guards its deepest secrets closely. Every few orbits, its radio emissions abruptly stop, replaced by 48 hours of perfect silence before resuming as if nothing happened. During these pauses, probes have detected faint vibrations inside the comet, as if something within is rearranging itself. One daring theory posits that the comet isn't just an instrument, it's a composer, its internal structure evolving to learn new patterns from its environment. Another suggests that the silence coincides with the comet passing near the dark vortex, hinting at a connection between these two enigmas. Whether it's a natural marvel or something more profound, the singing comet reminds us that the universe isn't just a silent void. It's alive with rhythm, with pattern, with music waiting to be heard. And somewhere in the darkness, a frozen maestro continues its solo, playing a tune older than time itself. Deep within NGC 262, where magnetic forces dance at the edge of comprehension, lies an object so tangled in possibility it defies conventional physics, the quantum knot. This swirling nexus of electromagnetic energy isn't just a chaotic snarl of forces. It's a cosmic labyrinth where the fabric of reality appears to fold back on itself, creating structures so intricate they might be stitching together the universe's seams. Picture a whirlpool of pure magnetism, its lines twisted into braids tighter than DNA, crackling with energy that flickers in and out of detectable existence. What makes the quantum knot so extraordinary isn't just its appearance, it's the way it behaves. Most magnetic fields in space stretch and arc like invisible ribbons, shaping nebulae and guiding stellar winds. But here, the fields loop into closed, self-reinforcing circuits, forming stable knots that persist for years without unraveling. Even stranger, these knots occasionally vanish from sensors entirely, only to reappear milliseconds later in a slightly altered configuration, as if they'd briefly slipped through a fold in space-time. Some researchers believe these fleeting disappearances could be evidence of microscopic wormholes, transient tunnels forged by the knot's immense magnetic torsion, linking distant parts of the galaxy in fleeting quantum shortcuts. Then there's the entanglement. Particles caught in the knot's grasp don't just move predictably, they become quantum-linked, mirroring each other's states instantaneously across light years. When one particle spins clockwise, its paired counterpart elsewhere in the galaxy spins counterclockwise, no matter the distance between them. It's as if the knot is weaving invisible threads through the cosmos, connecting points that should be isolated by the unbreakable speed limit of light. Under lab conditions, quantum entanglement is fragile, collapsing at the slightest interference. Yet here, in the chaos of deep space, it persists on macroscopic scales, defying decoherence with eerie stability. Theories about the knot's origins range from the sublime to the surreal. One camp suggests it's a natural byproduct of the galaxy's turbulent core, where colliding black holes or neutron stars might have twisted magnetic fields into these impossible configurations. Others propose something far more speculative, that the knot is a relic of the early universe, a frozen moment when the fundamental forces hadn't yet fully separated, leaving behind tangled pockets where electromagnetism and gravity still interweave. But the most tantalizing clue lies in the knot's heartbeat. Every 11 hours, its magnetic strands pulse in a coordinated ripple, a wave of energy that propagates through the knot like a shudder down a spider's web. During these pulses, nearby particles exhibit bizarre behavior, some gaining mass briefly, others teleporting nanometers to the side without crossing the intervening space. It's as if the knot briefly tightens, squeezing space-time itself until the usual rules no longer apply. Whether it's a natural wonder or a sign of physics beyond our grasp, the quantum knot challenges us to rethink the universe's most basic assumptions. If magnetic fields can tie space-time into knots, what else might be hidden in the folds? And if entanglement can thrive in the cosmic wild, what other quantum phenomena might be waiting untamed in the dark? Orbiting quietly at the edge of NGC 262's gravitational pull, the hollow planetoid is a cosmic riddle wrapped in a metallic shell. At first glance, it appears unremarkable, a small, pockmarked world no larger than Earth's moon, drifting through the void like countless other asteroids. But beneath its cratered exterior lies a mystery that defies planetary science. This object is almost entirely hollow. Scans reveal a structure unlike any natural celestial body. Its outer layer is a seamless alloy of titanium and an unknown metallic composite, thicker than Earth's continental crust yet unnaturally lightweight. Beneath this shell, not molten rock, not compressed gases, just empty space, interrupted only by a sparse lattice of geometric supports resembling the girders of a half-finished Dyson sphere. The planetoid's density is so bafflingly low that even ice would weigh more by comparison. If you could stand on its surface, your footsteps would echo through the cavernous interior like knocks on a cosmic front door. How could such an object form naturally? One theory suggests it's the remnant of a failed stellar engine, a megastructure designed to harness a star's energy, abandoned mid-construction and left to drift. The latticework inside might have once channeled unimaginable forces, its metallic skin engineered to withstand temperatures that would vaporize ordinary matter. Others propose it's a colossal seed pod, a vessel designed to carry something across interstellar distances, its hollow interior once home to cargo long since perished or departed. Then there's the sound. When seismic probes were dropped onto the planetoid's surface, they detected something unsettling. The entire structure vibrates at a low, resonant frequency, like a bell struck millennia ago that hasn't yet stopped ringing. The vibrations don't match any known geological activity. Instead, they pulse in perfect harmonics, as if the planetoid itself is humming a note from some alien scale. Perhaps the most chilling detail is its orbit. Unlike the erratic paths of most asteroids, the hollow planetoid traces a near-perfect circle around NGC 262's core, as if placed there deliberately. Some astronomers argue its trajectory is too precise to be accidental, a parking job executed with celestial precision. Whether it's a relic of some ancient civilization's ambitions or a freak of nature we don't yet understand, one thing's certain: this isn't just a rock. It's a message waiting to be decoded, and its silence speaks volumes. Stretching across the star-studded canvas of NGC 262 like a celestial tightrope, the light bridge is exactly what its name suggests: a luminous beam connecting two stars separated by nearly half a light year. This isn't the usual stellar flare or the wispy trail of a comet. It's a razor-thin filament of coherent light, unwavering in its intensity, as if someone threaded a needle through the cosmos and pulled it taut. Most mysterious of all, it shouldn't exist. Conventional physics tells us light disperses. Even laser beams, the most focused light humans can produce, eventually scatter over distance. But the light bridge defies this rule. Its glow remains perfectly collimated, no wider at its midpoint than at either stellar anchor. Spectrographs reveal it's not just visible light. The beam pulses with X-rays, infrared, and even faint gravitational ripples, as if it's not just a bridge of photons but a conduit for multiple energies. Some astronomers compare it to a cosmic fiber optic cable, channeling power between stars with impossible efficiency. What fuels this anomaly? The stars themselves offer no answers. Neither is particularly luminous or energetic. Just ordinary yellow dwarfs, the kind that might host uneventful planetary systems. Yet where the bridge meets their surfaces, telescopes detect intricate spiral structures, glowing coronas that twist like twin tornadoes funneling energy into the beam. One theory suggests the stars are entangled in a gravitational resonance, their magnetic fields braided into a stable pathway for charged particles, but that wouldn't explain the bridge's persistence. Gravitational interactions fluctuate. This light stays constant, its output varying by less than 0.1% over decades of observation. Then there's the eerie synchrony. When one star experiences a solar flare, the other echoes it precisely 10 minutes later, the exact time it would take light to cross the bridge's length. It's as if the stars are communicating, their energies perfectly mirrored across the gulf between them. Some researchers argue this could be evidence of quantum entanglement scaled to stellar proportions, a phenomenon previously only observed in lab-controlled particles. Others, more daring, speculate the bridge might be a repair mechanism, an engineered structure designed to stabilize a binary system on the brink of collapse. But perhaps the most tantalizing clue lies in the shadows. When asteroids or dust clouds drift through the bridge, they don't disrupt it. Instead, the light bends around them seamlessly, reforming on the other side like a self-healing wound. This behavior mirrors theoretical solitons, waves that maintain their shape while passing through obstacles. If natural, it's a staggering example of the universe's ability to self-organize. If artificial, it's a masterpiece of engineering, a technology that could revolutionize how we think about energy transmission across interstellar distances. One thing's certain: the light bridge doesn't just connect two stars, it bridges the gap between what we know and what the universe still hides. And somewhere in its glow there might be a lesson, or a warning written in photons older than life itself. Of all the cosmic oddities in NGC 262, few are as stealthy or as downright spooky as the vanishing moon. This isn't some dim, distant rock easily lost in the glare of its parent planet. It's a fully formed, Earth-sized satellite that orbits a gas giant on the galaxy's fringe until, without warning, it winks out of existence. One moment it's there, clear as day in telescope feeds. The next, nothing, just empty space where a moon should be. And then, days, weeks, or sometimes years later, it reappears exactly where it left off, as if it never vanished at all. What makes this moon so unsettling is the precision of its disappearances. Most celestial objects don't just vanish. They drift behind planets, get obscured by dust clouds, or dim under stellar eclipses. But this one, it's as if someone flips a switch, no fading, no distortion, just gone. And when it returns, its surface shows no signs of trauma. No fresh craters from rogue asteroids, no scorch marks from solar flares. It's as if time stops for the moon while the rest of the universe marches on. Theories about its behavior range from the scientifically rigorous to the wildly speculative. One camp argues the moon might be cloaked in some natural stealth material, a layer of exotic matter that bends light around it, rendering it invisible to our instruments. On Earth, we've toyed with metamaterials that can redirect radar waves. Could this moon be wrapped in a cosmic-scale version of that tech, either by nature or by design? Others suggest something even stranger, that the moon periodically slips into another dimension, a parallel reality where our laws of physics don't apply. If true, it wouldn't just be vanishing, it'd be traveling, popping in and out of our observable universe like a ghost through walls. Then there's the orbit. The vanishing moon doesn't just disappear at random. Its vanishings coincide with specific alignments, when its parent planet passes near the dark vortex or when the galaxy's core releases a surge of gravitational waves. It's almost as if these cosmic events act as doorways, briefly unlatching whatever holds the moon in our reality. Even stranger, the moon's reappearances sometimes precede bursts of radio noise from elsewhere in the galaxy, as if its return triggers some unseen ripple effect across spacetime. Perhaps the most chilling detail lies in the shadows. On rare occasions, the moon doesn't vanish completely. Instead, it flickers a fleeting glimpse of its surface replaced by something else. Blurred shapes, geometric patterns, lights that move in formations no natural phenomenon could explain. Are we catching glimpses of where the moon goes when it's not here? Or is something else catching glimpses of us? Whether it's a natural wonder or something far more mysterious, the vanishing moon forces us to confront a humbling truth. The universe doesn't just hide its secrets in the dark. Sometimes it hides them in plain sight, then snatches them away before we can look too closely. And every time this moon disappears, it takes a little more of our certainty with it. Imagine a world where the sky doesn't weep rain or snow, but diamonds. In the turbulent embrace of NGC 262 lies a planet so extreme, it turns cosmic violence into glittering treasure. The diamond storm isn't just a poetic nickname, it's a literal phenomenon. Here, hurricane-force winds whip through methane-rich atmospheres, compressing carbon into crystalline perfection, then hurling it sideways in blizzards of gemstones the size of grapes. This exoplanet's recipe for diamond hail starts with its crushing atmosphere, a soupy mix of methane and hydrogen under pressures that would flatten steel like tinfoil. When megastorms erupt, lightning bolts hotter than the sun tear through the sky, breaking methane molecules apart. Carbon atoms, suddenly freed, are driven deep into the planet's lower layers by 1,000-mile-per-hour winds, where pressure cooks them into raw diamonds. Normally, these gems would sink toward the core, lost forever. But on this world, updrafts from storm systems act like cosmic elevators, carrying diamonds back to the upper atmosphere where they freeze into solid pellets. The result, skies that don't just sparkle, they shred. What makes these storms even wilder is their scale. Unlike Earth's fleeting thunderstorms, diamond tempests here rage for centuries, their cycles fueled by tidal forces from a nearby neutron star. The planet's eternal night side acts as a diamond refinery, where endless darkness allows temperatures to plummet further, creating ideal conditions for crystals to form. Meanwhile, the day side, scorched by relentless stellar radiation, boils off fresh methane, feeding the cycle anew. It's a self-sustaining jewelry factory forged in chaos. Then there's the aftermath. Over millennia, diamond drifts have accumulated into glittering dunes miles deep, their surfaces reflecting starlight like fractured disco balls. Probes sent into the atmosphere, or what's left of them, detected something even stranger. The diamonds aren't pure. Trapped inside their crystalline structures are microscopic bubbles of exotic hydrogen, a form of matter that shouldn't exist outside a lab. Some scientists speculate these inclusions might be clues to the planet's origins. Perhaps it's the corpse of a gas giant, its core stripped bare by some ancient cataclysm. But the most dazzling detail, the diamonds sing. As storms churn them through magnetic fields, they generate eerie radio emissions pulses that mimic the harmonics of a xylophone struck by lightning. It's as if the planet isn't just making treasure, it's composing an anthem to its own extravagance. Whether it's a natural wonder or nature's most ostentatious prank, one thing's certain: this stormy world proves the universe doesn't just create beauty. Sometimes it hurls it at you. Drifting through the star-rich currents of NGC 262, the cosmic jellyfish is a nebula that seems ripped straight from an alien ocean. A luminous, undulating mass of ionized gas stretching over 15 light-years, its tendrils rippling like living tentacles in the solar wind. Unlike typical nebulas which glow with the chaotic energy of newborn stars, this structure pulses with eerie regularity, its bioluminescent hues shifting from violet to deep crimson in a rhythm that matches no known celestial cycle. It's as if the universe itself has a heartbeat, and this is where it echoes loudest. What makes the jellyfish so mesmerizing isn't just its appearance, it's the way it moves. Those trailing tendrils aren't static filaments. They coil and uncoil with deliberate grace, as if guided by some unseen current. Telescopes have captured them stretching outward at speeds that defy the nebula's own expansion, like limbs reaching for prey. Even stranger, the tips of these tendrils occasionally detach, floating away as self-contained orbs of plasma that glow independently for weeks before dissipating. Scientists initially dismissed them as stellar flares, but their trajectories are all wrong. They curve back toward the nebula's core, as if tugged by invisible strings. Then there's the pulse. Every 11 hours and 36 minutes, the entire nebula brightens by precisely 18%, its core flaring like a lighthouse beacon. The light isn't thermal radiation, though. Spectrographs reveal it's coherent, tightly focused, like laser light, a phenomenon unheard of in natural cloud structures. One theory suggests the jellyfish might be threaded with superconducting filaments, remnants of a shattered magnetar whose magnetic fields now choreograph the nebula's dance. Others point to the way its pulses occasionally sync with emissions from the radio pyramid, hinting at a hidden dialogue between these distant anomalies. But the most haunting detail lies in the shadows. When probes attempted to map the nebula's interior, their sensors detected voids, regions where matter simply stopped, as if something inside were carving out pockets of absolute nothingness. These voids shift positions unpredictably, sometimes merging, sometimes vanishing entirely. Are they scars from ancient stellar collisions, or something more unsettling, evidence that the jellyfish isn't just a cloud of gas, but a cosmic predator, its tendrils not just beautiful but functional? Whether it's a natural marvel or a sign of forces we've yet to understand, the cosmic jellyfish reminds us that the universe doesn't just create chaos. Sometimes it moves with a purpose, a rhythm we're only beginning to hear, and in its pulsing light there might be a message or a warning written in wavelengths we've yet to decode. Among the many cosmic wonders of NGC 262, one stands out not for its size or brilliance but for its terrifying potential. The antimatter fountain isn't just another jet of exotic particles. It's a towering geyser of pure annihilation, spewing streams of antimatter into the void with the grace of a celestial waterfall, and the destructive force of a cosmic detonation waiting to happen. Picture this, a slender column of ultra-high-energy particles, stretching nearly 2 light-years from its unseen source, shimmering with an eerie blue-white glow. Unlike ordinary plasma jets, which fade as they disperse, this fountain remains tightly focused, its antimatter streams resisting the usual scattering forces of space. The effect is breathtaking and lethal. Every atom of ordinary matter that drifts too close meets its mirrored counterpart in the fountain, vanishing in a silent flash of gamma rays. It's like watching a river dissolve rocks on contact, leaving behind only energy and emptiness. The fountain's origin is as puzzling as its behavior. Deep at its base, sensors detect a swirling vortex of energy, but no visible object, no black hole, no neutron star, no collapsed remnant that could produce such a focused antimatter stream. Some theories suggest it might be fed by a quantum anomaly, a flaw in spacetime where virtual particles, normally fleeting pairs of matter and antimatter, are somehow ripped apart before they can recombine. The antimatter gets funneled upward while the matter counterpart vanishes into the vortex, as if the universe itself has sprung a leak in one direction. Then there's the risk. Most antimatter in space is sparse, isolated atoms colliding too rarely to pose a threat. But this fountain is dense, concentrated. A single gram of its antimatter, if transported near Earth, would release energy equivalent to 43 kilotons of TNT, twice the yield of the Hiroshima bomb. And this fountain isn't just grams, it's tons per second, a relentless torrent that could erase a planet if it ever changed course, even more unsettling. The jet's path is shifting. Over the past century, telescopes have recorded a slight curvature in its trajectory, bending toward a nearby star cluster. Whether it's drawn by gravity or some unseen force, one thing's clear: this isn't a static spectacle. It's a slow-moving cataclysm, yet for all its danger, the fountain holds tantalizing secrets. Antimatter is the universe's rarest commodity, a substance that should have vanished entirely after the Big Bang. Finding it in such abundance challenges our understanding of cosmic balance. Could this be a remnant of a primordial imbalance, a pocket where the universe's initial symmetry never fully broke? Or is it something more deliberate, a cosmic refinery producing antimatter for purposes we can't fathom? As the fountain continues its silent, deadly flow, astronomers watch with equal parts awe and unease. It's a reminder that the universe doesn't just create, it destroys. And sometimes it does both with the same breathtaking beauty. Hovering in the depths of NGC 262 like a cosmic tableau, the frozen supernova is a stellar explosion caught in an impossible pause. This isn't the usual smoldering remnant or the fading glow of a star's last act. It's a detonation suspended mid-blast, its fireball frozen in a perfect sphere of searing plasma, as if someone hit the universe's pause button. The shockwave rippling outward from the core should have dissipated millennia ago, yet here it remains, crystallized in a single, terrifying moment of destruction. What makes this supernova so unnerving isn't just its stillness, it's the way time behaves around it. Sensors trained on the remnant reveal clocks ticking slower the closer they get to its boundary. A probe sent to study the phenomenon aged only a few hours during its approach, while mission control logged weeks of elapsed time back home. It's as if the explosion's violence warped space-time into a recursive loop, trapping itself, and anything that ventures too near in a bubble of perpetual almost. Theories about its suspended state range from the plausible to the mind-bending. Some astrophysicists argue the supernova's core might have collapsed into an exotic form of matter, a quark-gluon plasma so dense it effectively freezes gravitational interactions at its surface. Others suggest the star's explosion triggered a localized spacetime defect, a kink in the fabric of reality where cause and effect no longer flow in one direction. But the most haunting possibility, that the supernova did finish exploding long ago, and what we're seeing is a memory, a fossilized echo of the event preserved in a region where time has folded back on itself. Then there's the light. The frozen supernova doesn't emit the usual afterglow of radioactive decay. Instead, its spectral lines repeat in perfect, unchanging cycles, like a broken record of a star's death scream. Even stranger, the light's polarization shifts in geometric patterns, as if the explosion's energy is trapped in some cosmic feedback loop, bouncing between dimensions we can't perceive. Whether it's a natural time capsule or a rift in the laws of physics, the frozen supernova forces us to confront a chilling truth. Some cosmic events are too powerful to fade. They linger, suspended between moments, reminding us that even time, the universe's most relentless force, can stumble. And somewhere in that frozen fireball, the star's final act waits, eternally unfinished, for a universe that may never hit play. Buried in the silent depths of NGC 262, the whispering void doesn't just consume light, it speaks. This supermassive black hole, with an event horizon wider than our solar system, emits no radio chatter, no X-ray screams. Instead, it broadcasts in a language older than stars, the faint, rhythmic tremors of gravitational waves, vibrating through the fabric of space-time like a cosmic drum. But these aren't random ripples. They arrive in precise, repeating sequences, patterns so deliberate they've sparked a radical question. Could this be the universe's first natural code? Unlike the violent mergers that typically generate gravitational waves, the whispering void's signals are eerily consistent, pulsing in clusters of 3 short waves followed by 2 long ones, repeating every 6 hours and 17 minutes with atomic clock precision. It's as if the void is tapping out a message in celestial Morse code. When researchers first detected the pattern, they assumed instrument error. But as the signals persisted across multiple observatories, the truth became undeniable. This black hole isn't just humming. It's communicating. Theories about the source of these whispers divide the scientific community. Some argue it's a gravitational echo, where matter spiraling into the black hole gets trapped in a resonance loop near the event horizon, vibrating space-time like a wineglass singing to the touch of a wet finger. Others propose something more exotic, that the void's spin has warped nearby space-time into a kind of gravity horn, amplifying and modulating the waves into coherent patterns. But the most tantalizing hypothesis that these waves carry information. Gravitational waves encode data about their origins, the mass of colliding objects, their spin, even the shape of the space-time they warp. The whispering void's patterns, however, contain anomalies, subtle asymmetries and harmonic overtones that mirror error-correcting algorithms in human digital signals. It's as if the black hole isn't just vibrating, but encoding, transmitting details about its own structure, or perhaps something far stranger. Then there's the silence between whispers. For exactly 42 minutes after each transmission, all gravitational activity near the void ceases entirely. No starquakes, no matter collisions. Just perfect stillness, as if the cosmos itself holds its breath. During these pauses, deep-field telescopes have detected faint, ultraviolet afterglows around the event horizon, brief flickers that some researchers interpret as recharging, like a cosmic capacitor gathering energy for its next broadcast. Whether it's a natural phenomenon or something more profound, the whispering void forces us to reconsider what black holes are. Not just destroyers of light, but potential archivists, broadcasters, even storytellers. And if we ever learn to fully decode its murmurs, we might discover it's been trying to tell us something all along, something written not in words, but in the very curvature of reality. Somewhere in the tangled starscape of NGC 262, the universe keeps perfect time down to the trillionth of a second. Meet the celestial clock, a pulsar system so precise it makes atomic clocks look like sundials. This isn't just a spinning neutron star, it's a cosmic metronome, emitting pulses so regular they could set your watch by them. Every 1.337 seconds without fail, a beam of radio waves sweeps past Earth like clockwork, a rhythm unbroken for the entire 40 years we've observed it. No stellar wobble, no drift, just the quiet, relentless ticking of a natural timepiece older than human civilization. What sets this pulsar apart isn't just its consistency, it's the eerie perfection of its mathematics. Most pulsars gradually slow as they age, their spins decaying like unwound springs. Not this one. Its rotation period hasn't varied by more than 1/4 of a second since its discovery, a stability that defies every model of stellar evolution. Some researchers compare it to a gyroscope locked in cosmic balance, its spin perfectly counteracting the drag of its own magnetic field. Others whisper about darker possibilities, that the pulsar might be artificially stabilized, its rhythms fine-tuned by forces we don't yet understand. The clock's potential as a universal timekeeper has astronomers buzzing. Imagine a navigation system where spacecraft triangulate their positions not by satellites, but by the pulses of a distant neutron star, a GPS spanning light years instead of continents. Already, proposals exist to use pulsar timing arrays for interstellar travel, with the celestial clock as their crown jewel. Its signals are so clean, so predictable, they could guide probes to Alpha Centauri with meter-scale accuracy. Yet the clock guards its secrets fiercely. Buried in its otherwise flawless pulses are microsecond glitches, tiny hiccups where the rhythm stutters, then resets. These anomalies cluster in Fibonacci sequences, a mathematical pattern found in everything from sunflower seeds to spiral galaxies, coincidence or evidence of some deeper cosmic synchronization. Then there's the companion, orbiting the pulsar at exactly 1/10 the distance of Mercury from our Sun, is an object too dim to see, yet massive enough to warp the clock's pulses with its gravity. Every 28 years, as it completes its elliptical orbit, the pulses slow imperceptibly, not from decay, but from Einstein's time dilation, the drag of spacetime itself. This dance between precision and relativity makes the celestial clock more than a curiosity. It's a laboratory where the universe tests its own laws. Whether natural masterpiece or engineered wonder, one thing's clear. In a cosmos of chaos, the clock ticks on a heartbeat so steady, it might just outlast time itself. Gliding silently through the interstellar void of NGC 262, the ghostly armada moves with an eerie, regimented precision. A fleet of thousands of ship-like objects, each translucent as blown glass, arranged in perfect diamond formations across the darkness. These aren't asteroids or rogue comets. They're smooth, elongated structures, some stretching kilometers long, their edges too uniform, their trajectories too synchronized to be the work of chance. When telescopes first captured their faint silhouettes against the backdrop of the galaxy, researchers assumed an imaging error, but the truth was far stranger. The armada was real. And it was moving together. What makes these phantom vessels so unsettling is their composition. Scans reveal they aren't made of rock or metal, but something far more exotic, a hyper-dense plasma lattice, a state of matter that should be unstable in the vacuum of space. Yet here it holds its shape, seemingly frozen in a phase between gas and solid, shimmering like ice under moonlight. Even weirder, the objects are cold. Unlike stars or nebulae, they emit no heat signatures, no infrared glow. Just a faint blue-white luminescence that pulses in unison every 17 hours, as if the entire fleet shares a single, silent heartbeat. Theories about their origins range from the mundane to the mind-bending. One camp argues they're the remnants of a shattered magnetar, its crust torn apart by gravitational tides and frozen into these haunting shapes. Others suggest they're cosmic snowflakes, naturally occurring plasma crystals grown to monumental scales in the galaxy's unique magnetic fields. But the most tantalizing hypothesis: that they're not natural at all. Their formations mimic human naval tactics, flanking maneuvers, scouting patterns, even staggered retreats, with an intelligence that raises uncomfortable questions. Could these be relics of some ancient civilization's fleet, preserved in a state between existence and oblivion? Then there's the mystery of their movement. The armada doesn't drift aimlessly, it navigates. When a star or black hole lies in its path, the fleet adjusts course months in advance, shifting formations with a grace that defies inertia. There's no visible propulsion, no engine flares or ion trails, just smooth, anticipatory corrections, as if the void itself guides them. Some astronomers speculate they're riding gravitational currents too subtle for our instruments to detect. Others whisper about quantum entanglement, with each ship bound to the others across light years, moving as a single entity. But the most haunting detail: they're learning. Over decades of observation, the Armada's patterns have evolved. Early reconnaissance showed simple geometric arrangements. Now the formations grow increasingly complex fractal designs, nested spirals, even what appear to be symbols etched in starlight. One recurring pattern matches the Fibonacci sequence with unnerving accuracy, a mathematical fingerprint rarely seen outside organic growth. Whether they're natural wonders or something more profound, the ghostly Armada forces us to confront a spine-tingling possibility that we might not be the only ones watching the stars. And somewhere in the dark, something else has been sailing them for far, far longer. Amid the chaos of NGC 262's swirling gases, the plasma sculpture hangs like a masterpiece in an unseen gallery, a floating, twisting ribbon of ionized particles stretching nearly 10 light-years across, its curves so deliberate they look chiseled by an artist's hand. This isn't the usual turbulent plasma filament writhing under magnetic forces. It's a frozen ballet of superheated matter, each loop and spiral holding its shape against the galaxy's relentless currents, as if defiance of entropy were its sole purpose. What makes this structure so mesmerizing isn't just its beauty, it's the physics-defying stability at its core. Plasma, the universe's most tempestuous state of matter, should shred itself apart in seconds under these conditions. Yet here, the sculpture endures for centuries, its form resisting the drag of interstellar winds and the pull of nearby black holes with eerie resilience. Telescopes have captured its edges rippling like silk in a breeze, yet never unraveling, never dispersing. It's as if the sculpture exists in a pocket of space where the usual rules of electromagnetism and fluid dynamics no longer apply. Then there's the design. The sculpture's strands aren't random. They repeat geometric patterns, golden ratios, Fibonacci sequences found in everything from Nautilus shells to spiral galaxies. Some segments coil into perfect double helices, mirroring the structure of DNA. Others flare into fractal branches, each smaller than the last, down to scales so fine they challenge telescope resolution. Natural processes rarely produce such precision without an external force. So what or who could be the sculptor? One theory points to the galaxy's unique magnetic topography. NGC 262's core hosts a tangle of black holes and neutron stars, their combined fields weaving a labyrinth of invisible forces. Perhaps the sculpture is a cosmic fingerprint, plasma molded by these intersecting energies like iron filings aligning on a magnet. But that wouldn't explain the changes. Over decades, certain sections of the sculpture have shifted, not eroded, but morphed, as if responding to an unseen hand. A spiral tightens here, a tendril elongates there. It's less like a static formation and more like a work in progress. Then there's the light. The sculpture doesn't just glow, it pulses, cycling through hues from cobalt to violet in sync with emissions from the radio pyramid, half a galaxy away. Coincidence? Unlikely. Some researchers suggest these pulses could be resonance patterns, evidence the sculpture is part of a larger, galaxy-scale circuit, funneling energy between anomalies like a cosmic wire. Others propose something more daring, that the structure isn't a byproduct of nature, but a message, a monument, an artwork inscribed in plasma, waiting for eyes sharp enough to read it. Whether it's a natural wonder or something more profound, the plasma sculpture challenges us to reconsider where beauty ends and intention begins. And as its filaments twist silently against the dark, one thing becomes clear: the universe doesn't just create chaos. Sometimes it composes, hidden in the glare of one of NGC 262's brightest stars. A cosmic jigsaw puzzle has astronomers rethinking the boundaries between nature and engineering. The Dyson Swarm isn't just another debris field or asteroid belt. It's a vast, shifting maze of massive objects orbiting in unnervingly precise formation. blotting out their parent star's light in rhythmic, intentional patterns. Picture a hive of geometric shadows, hexagonal panels, spiraling ribbons, even tessellated spheres all moving in concert, their combined dance dimming the star's brilliance by nearly 40%. This isn't random chaos, it's orchestrated. The swarm's resemblance to theoretical Dyson spheres, hypothetical megastructures built by advanced civilizations to harvest a star's energy, is impossible to ignore. Unlike natural debris, these objects reflect almost no starlight. Their surfaces appear engineered to absorb, not scatter, photons. Thermal scans reveal something even stranger. The swarm's temperature is uniform, as if each component radiates heat evenly despite varying distances from the star. In nature, such equilibrium is unheard of. Even more telling, the shadows they cast aren't black. They glow faintly in the mid-infrared spectrum, suggesting energy is being collected, converted, and perhaps even stored or transmitted elsewhere. Fermi paradox implications loom large here. If this is artificial, where are the builders? The swarm shows no signs of active construction, no flares of welding, no propulsion trails. Just silent, perfect motion, like a clockwork relic left ticking long after its makers vanished. One chilling theory posits that the swarm isn't dormant at all, but operates autonomously, its creators having long since transcended the need for physical presence. Alternatively, it might be a beacon, a galactic-occupied sign meant to deter visitors. Or perhaps we're witnessing a post-biological civilization's final project, a star slowly dismantled by machines with no one left to command them. Yet nature, ever the contrarian, offers counter-arguments. Could this be an exotic protoplanetary disk, its dust particles aligned by magnetic fields into unnatural-looking structures? Some models suggest hyper-efficient heat distribution might arise in systems with rare elemental compositions, but these explanations falter under scrutiny. No known natural process accounts for the swarm's fractal symmetry or its eerie synchronization with pulses from the radio pyramid elsewhere in the galaxy. The most tantalizing clue lies in the shadow's motion. Every 18 years, the swarm's components rearrange into a new configuration, each shift optimizing light-blocking efficiency to within a fraction of a percent. It's as if something or someone is fine-tuning the system, refining it toward an unknown purpose. Whether artifact or anomaly, the Dyson swarm forces a humbling admission. Some cosmic puzzles don't just challenge what we know. They ask us who else might already know the answers. Drifting alone through the eternal night between stars, the rogue planet with rings is a celestial nomad dressed in impossible finery, a world without a sun, yet adorned with a ring system so vast and intricate it puts Saturn to shame. These aren't just faint bands of debris, they're a dazzling, layered tapestry of ice and rock stretching nearly twice the planet's diameter, glimmering like a halo in the void. What makes this wanderer so mesmerizing isn't just its beauty, it's the defiance of physics that keeps its rings intact, untethered to any star's gravity, surviving the chaos of interstellar space against all odds. How does a planet without a solar system retain such extravagant rings? The answer lies in a delicate dance of forces. Most ring systems rely on their parent star's gravity to stabilize them, or they're torn apart by nearby planets. But this rogue world carries its own guardians, a retinue of shepherd moons, each no larger than a city, orbiting just beyond the ring's edges. These tiny sentinels nudge stray particles back into place with gravitational precision, their coordinated movements preventing the rings from spreading into oblivion. It's a self-sustaining ballet where moonlets and debris move in lockstep, a closed ecosystem of motion that requires no external force to endure. Then there's the planet itself, a frozen giant, its surface a labyrinth of methane glaciers and nitrogen geysers, erupting in slow-motion plumes that freeze midair and fall as diamond snow. Without a star to warm it, the world's core generates its own heat through radioactive decay. churning its mantle into a superconducting dynamo that powers auroras brighter than Earth's, rippling across its skies in curtains of electric blue. These auroras, in turn, ionize the inner rings, charging them into luminous plasma loops that pulse like neon signs in the darkness. But the real mystery is how this planet acquired its rings in the first place. One theory suggests it was once a proud member of a solar system, until a close encounter with a passing star or black hole flung it into the abyss, its rings miraculously surviving the ejection. Another proposes something far stranger, that the planet's rings aren't debris at all, but the remains of a shattered moon torn apart by tidal forces during the planet's exile. The composition of the rings supports this. Spectral analysis reveals veins of exotic minerals that typically form only under extreme pressures, hinting at a cataclysmic origin. Yet the most haunting detail is the rings' motion. Unlike Saturn's orderly bands, these rings undulate in slow, sinuous waves as if breathing. Some sections spiral inward, feeding material onto the planet's poles in shimmering waterfalls of ice. Others ripple outward, extending tendrils into space like exploratory fingers. It's as if the rings aren't just a static ornament, but a living extension of the planet's will, a dynamic, ever-changing boundary between the world and the void. Whether it's a cosmic fluke or a testament to nature's resilience, the rogue planet with rings stands as a monument to solitude. It reminds us that even in the deepest loneliness, the universe finds ways to astonish, to clothe its orphans in splendor and set them adrift, glittering against the dark. Deep in the tangled starfields of NGC 262, a single object broadcasts a riddle wrapped in wavelengths, an anomaly astronomers call the cosmic riddle. Unlike pulsars with their rhythmic beats or quasars blasting raw energy, this enigmatic source transmits in layers, its signals stacked like pages of an alien encyclopedia. Radio waves whisper in prime-numbered pulses, X-rays flicker in fractal patterns. Even its infrared emissions carry a peculiar structure, rising and falling in waves that mirror the base pairs of DNA. It's as if the universe itself left a multi-sensory puzzle floating in the dark, and we're only beginning to piece it together, the riddle's complexity unraveled over decades of observation. Early radio telescopes in the 1970s first noted its unusual bursts, dismissing them as interference. Then, in 2008, a deep space array caught something extraordinary, the same sequence simultaneously in 3 different wavelengths. Not echoes, not reflections, identical data streams riding radio, gamma, and ultraviolet light perfectly synchronized. Natural phenomena don't coordinate like this. Stars don't transmit in harmony across the electromagnetic spectrum. Yet here was an object doing exactly that, its signals aligned down to the nanosecond. Attempts to decode the patterns have spawned entire research fields. The most promising breakthrough came from a team at the Atacama Observatory, who noticed the radio pulses mapped onto a 3-dimensional lattice when graphed over time, a structure eerily similar to the atomic arrangement of silicon crystals. Was this a blueprint, a map, or mere cosmic pareidolia, our brains forcing order onto randomness? Skeptics argue the riddle could be a rare plasma resonance, where turbulent magnetic fields sculpt emissions into pseudo-patterns. But that doesn't explain the redundancy, the way critical data repeats in multiple wavelengths, as if ensuring at least one version survives the chaos of interstellar space. Then there's the evolution. Last year, the riddle's output shifted. Its radio pulses began encoding error-correcting algorithms, the same mathematical safeguards used in human digital communications to fix corrupted data. Coincidence stretches thin here. Either we're witnessing the universe's most elaborate natural accident, or someone is optimizing their broadcast for an audience just learning to listen. Perhaps the most haunting detail is the silence. For 11 minutes each day, the riddle goes dark. Not random static, not solar interference, a precise, scheduled pause as if waiting for a reply. Efforts to transmit responses during these windows have so far yielded nothing but echoes. Yet the riddle persists, its signals growing clearer with every passing year, as if whatever's sending them is patiently adjusting the frequency, tuning itself to a universe that might one day understand. Whether it's nature's symphony or a message in a bottle, the cosmic riddle forces a humbling admission. Some codes aren't meant to be cracked quickly. Some secrets unfold across generations, and somewhere in the silence between its pulses, there might be an answer or another question waiting for the right moment to be heard. From the glowing hexagon that defies geometry to the haunting whispers of the quantum knot, NGC 262 isn't just a galaxy, it's a cosmic cabinet of curiosities, each object more baffling than the last. We've wandered through 30 of its strangest wonders, twin black holes locked in a gravitational tango, a rogue planet wearing rings like a crown, and a Dyson swarm that might just be the universe's most ambitious construction project. We've marveled at nebulas that remember light, pulsars that echo like ghosts, and a monolith so perfect it seems carved by unseen hands. But here's the thing, these aren't just isolated oddities. Together, they paint a picture of a galaxy that plays by its own rules, where the laws of physics stretch like taffy, and the line between natural and engineered blurs beyond recognition. Maybe NGC 262 is a cosmic laboratory, a place where the universe tests its wildest ideas, or perhaps it's a message, one we're only beginning to decode. So what do you think? Is the fractal galaxy nature's masterpiece or something more deliberate? Could the radio pyramid be a beacon or just a stellar coincidence? The truth is, we don't have all the answers yet, and that's the beauty of it. Every mystery in NGC 262 invites us to look deeper, question further, and wonder a little louder. If these cosmic enigmas left you as awestruck as they left us, hit that subscribe button because the universe has endless secrets to share, and we're just getting started. And hey, drop your wildest theories in the comments. Who knows, maybe your idea will be the key to unraveling one of these celestial riddles. Until then, keep looking up. The cosmos is stranger and more spectacular than we ever imagined.